Hi there, grade 12s. I was asked to work through a few questions from the Eastern Cape September 2023 paper, the paper 2, chemistry paper. So the one question 1.1, they ask which one of the following has the strongest intermolecular forces. Now, the best way to answer this question is to just spend some time to draw out the molecules. A is C with 3 H's, C, and then there's a double bonded O on that carbon, and then another C. So this is propanone, the smallest ketone we can get. Now, the carbon-hydrogen bond in the molecules are slightly polar, with the hydrogen atoms polarized positively. So these carbon atoms at the ends will lead to London forces, or momentarily dipole forces existing between molecules. But the molecule has a C double bond O bond, and that oxygen there will lead to dipole forces. So here we have London forces or dipole forces between molecules. The second compound has a similar structure, but it's an aldehyde with its formyl group. There the functional group is carbonyl. Here the functional group will be the formyl group. So this is the molecular structure. As you can see, most of the molecule has hydrogen atoms. There would be London forces between the molecules of a kind. And here we have the dipole sticking out more than what it will be in a ketone. So here we have London forces as well as dipole. But I think these dipole forces might be slightly stronger than the dipole forces there. If you look at a graph of boiling point against molecular mass for the aldehydes and the ketones, then you'll see they're very much similar. Number C is an alcohol, 1-propanol, and because the oxygen there has a bond to the carbon that is polar covalent, as well as a bond to hydrogen that is strongly polar covalent, this is the first molecule in the 4 molecules that we are looking at, where you'll have London forces due to the carbon atoms being bonded to hydrogen atoms. But here you'll have, on the hydroxyl, you'll have a possibility of hydrogen bonding. So here we have London forces as well as hydrogen bonding. The fourth option here is a carboxylic acid. Now, carboxylic acids are formed between have the carboxyl group as its functional group, and it's got 2 sites for hydrogen bonding. Because of the 2 sites for hydrogen bonding there, here, so the oxygen has a possibility for hydrogen bonding with another molecule, and the hydroxyl has a possibility of hydrogen bonding with another molecule. So here we have London forces and we have hydrogen bonding but 2 sites. So these carboxylic acids, because of the 2 sites for hydrogen bonding, has got the strongest intermolecular forces between the molecules. Right, so this video covers question 1.1, and I'm going to stop it and then move on to the next question asked.